Now over here, writing it as a single fraction in its simplest form, yes, I know that we often say denominator has to be the same when we're doing addition or subtraction. But you don't just blindly go and multiply all the denominators together. Because when you do so, you will get a power 3 in the denominator. Then after that, you have to factorize it out again. In e-maths, I have not seen a question where we have to multiply the denominator such that we will result in a power 3 yet. Not that it cannot be, but I've not seen it before. Look closely at the denominators. This is 3x minus 1, this is 1 minus 3x. Do they look really similar to each other? Yes, right? Can I convert 1 minus 3x to become 3x minus 1? Yes, I can. So from here, the next step, 3x minus 1 square. I keep everything first. I'm going to show you step by step how we change 1 minus 3x to become 3x minus 1. 3x minus 1 with a minus sign in front. Doesn't this give us 1 minus 3x? Okay, so you have to recognize that this is equivalent to the original question. The reason why we are doing this is because we want the 3x minus 1 to appear again. Then we've got this irritating negative sign in front of the bracket, right? How about we multiply this negative with this negative? That gives us a positive. And this is now rewritten in an equivalent form. We just started going through on question 6. Okay, now the denominators are almost the same. But we have to ensure that they are exactly the same before we can add. So quite clearly, we have to square this. Then we have to multiply this by 3x minus 1. Put them in one single fraction with a denominator of 3x minus 1 square. We have 7 plus 15x minus 5. Okay, so we have 15x plus 2 over 3x minus 1 squared. Yes? Sorry? Can you have negative? What do you mean? Negative 3x what? Negative 15x minus 2. That is wrong already. What about the denominator? Same, then your answer is wrong. 1 plus 3x as the denominator will also not be correct.
1 minus 3x.
1 minus, okay. Denominator, let's just look at the 3x minus 1 square versus 1 minus 3x square. Is there a difference? Is there a difference in these two? Okay, sorry, let me write it right side up. 3x minus 1 is so irritating. Square versus 1 minus 3x square. Okay, got difference or not? Looks like there's a difference, right? But Jiao Hao say no difference. Let me show you. 3x minus 1. If I want to change it to 1 minus 3x, what do I have to do with it? Times negative 1, right? Okay, so inside my big square, nothing changed. I'm going to change my 3x minus 1 to become 1 minus 3x with a negative sign in front, isn't it? Now can you see that these two are the same? Right? We've got an outside square, we've got a bracket, and inside the bracket I've got 3x minus 1, and this is also 3x minus 1. Now I'm going to expand this. This is a negative 1 multiplied by 1 minus 3x. So I'm going to square negative 1, and I'm going to square 1 minus 3x. Can you now see that they are the same? 1 minus 3x with a square. Same? So these two, you have to recognize that they are equivalent. Can I move on? Yes? As long as you can combine them into one fraction correctly, I give you 1 mark. Combine into one fraction correctly, I give you 1 mark. But the denominator has to be power 2. If you combine with a denominator power 3, then that's not helpful. Okay, any other marks, clarification, please see me later, huh? I need to complete what I need to go through. Okay, question 7. We haven't seen this question in our TYS yet, right? For all the papers we have done. Because this is a rather recent type of question that they want us to deal with. In the recent 3-4 years, every year there will be a misconception question like this. Misleading graph. State one aspect that may be misleading and explain why it may lead to a misinterpretation. There are 2 parts to this. State the aspect and explain how it may lead to misinterpretation. Many of you correctly identified the vertical axis does not start from 0. It started from 25. But you do not know the significance of that. In addition, when you talk about the vertical axis, you have to say vertical axis. You cannot say y-axis. Because nowhere in this question is there a y. Okay? So the first aspect that we're going to be talking about is that the vertical axis does not start from 0. So what? So what if it didn't start from 0? That is the question you have to be asking yourself. How will this lead to a misinterpretation? Without looking too carefully at the vertical axis, based on the visual aspects of this graph, does it look like the revenue in year 1 is many times less than the revenue for year 2? Looks like, right? It looks like it is probably like 1/3 of it, isn't it? Then if you were to compare with the rest, and I think you get the idea already, or we could even say that year 1 revenue is 1, 2, 3, 4, 1/5 of year 4's revenue, right? That is if you don't look closely at the vertical axis. Now that we notice that it didn't start from 0, it started from 25. 25 what? 25,000. Now that we realize it started from 25,000, this value is actually 30,000. This value over here is actually 40,000. This is, okay, I can't really tell what this is. But that's not the main point. This is 50,000. Earlier, when we didn't look at the vertical axis, we felt that year 1 was 1/3 of year 2. But is that truly the case? No, it is not. It is actually just 10,000 less than year 2. Now, 10,000 out of what? Whether you take 10,000 out of 30,000 or 10,000 out of 40,000, it will still not result in such a great difference visually. Okay? So what is happening over here is an exaggeration of the difference. There is an exaggeration of the difference by presenting the graph in this manner. What would an accurate graph look like? We stretch it all the way down. If this is 25, this is 20, 15, 10, 5, and this is now my horizontal axis. Okay, and all these graphs, they are supposed to look like this. Do you get what I'm saying? Now, with this as the proper graph, will you still think that year 2 is actually 3 times of year 1 in terms of revenue? Now you wouldn't, because you see the full picture. How did this happen? Because of the effect of not starting from 0. It caused year 2's difference, the difference between year 2 and year 1 to be greatly exaggerated. Okay? So that is how it leads to a misinterpretation. Okay, how do we put it down in words? We say, yes, correct, the vertical axis does not start from 0. And we can continue by saying, okay, so this is what is suggested. Hence, it gives the impression of a large increase from year 1 to year 2. The first part is the aspect, what we observe. The second part is how it leads to a misinterpretation. As we continue with the more recent 10-year series questions, we will see how else this kind of graphs can also misrepresent information. Yes? Okay, that is one of those recent questions in our TYS. Look at 2019, 2018, 2017. They use drawings to represent data, which is not recommended also, because it's misleading. Okay, moving on. Question 8. Very badly done. Quadratic graph cuts the x-axis at -2 and 3. So we know that quadratic graph has to look like this: ax squared plus bx plus c. Right? This is a quadratic graph. Many of you think that a quadratic graph can also be written like this: x plus d, x plus e. Okay, many of you think that it can be written like this. You are partially correct. Why? If you were to expand this, what is your coefficient of your x squared? You are constraining yourself to have a coefficient of 1 for your x squared. Do all quadratic equations have to be 1x squared? No, it could be something x squared, right? So by doing this, x plus d, x plus e, I'm sure you're going to be limiting yourself to only a small range of answers. So knowing that there could be a coefficient over here, or there should be a coefficient, that might not be 1. How will we rewrite our quadratic equation? We can put an a in front. By doing so, we will end up with a ax squared plus da 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 da, and you can figure out the rest yourself. Okay? If you want to write a general form for your quadratic equation, it has to look like this or this. So with that, let's see how we can use this to solve the question. It cuts the x-axis at -2 and x goes to 3. So from your experience, you should know that it has to look something like this: x plus 2, x minus 3. If you have this as your answer, then you will definitely not get a mark. Why? Because if you were to substitute this, x equals to -3, x equals -3, your right hand side equals to -3 plus 2, -3 minus 3. So this is 6. Your right hand side is 6. Logic, your basics tell you that this right hand side is not equal to the left hand side, which is 5. Right? So when you come to this, you have to realize that something is wrong already. You cannot keep trying to continue from here. The conclusion at this point is that it's wrong. So to make it correct, we have to put a in front. Okay? Because we haven't taken into account this value of a. So now is the time for us to put in -3 for all the x values, and we put in the 5 for the y value. So substitute at -3, 5. We have 5 equals to a times of -3 plus 2, -3 minus 3. So early on, you calculated that this was 6. A equals to 5 over 6. So the equation of the graph is y equals to 5 over 6, x plus 2, x minus 3. No need to expand. If you want to expand, also okay. Okay, if you were to expand this, you will see that the coefficient of x squared is 5 over 6. And if you are thinking, how come I didn't know this before? I thought I've always managed to solve all the quadratic equations with my previous knowledge. The reason is because when the question says, find the x-intercept of this graph. When they tell you to find the x-intercept of this, what will you do? Set equal to 0, right? When you set equal to 0, what do you do with the 5 over 6? just ignore it already. Because you divide both sides by 5 over 6. So no matter what this value is, 5 over 6, 3, -1, 10, 1 million, as long as I ask you to solve it, when it is equal to 0, it will just disappear. And we will still get the same roots of -2 and 3. So that is the reason why many of you, straight away, your first step, y equals to x plus 2x minus 3. And gone already, cannot continue already. Okay, so there's an A over here. Next, question 10. 10A is very well done. 10B was not very well done. The mass of cylinder A is 250 grams. Find the mass of cylinder B. The mass, you have to know that it is directly proportional to volume. The greater the mass, the greater the volume. They are directly proportional. So this is actually asking us to think about the volume of cylinder B. These two are similar figures. So mass of B over mass of A must be equal to volume of B over volume of A, which is the radius of B over radius of A power 3. This is the relationship that we need. Substituting all the information we have, mass of A 250 grams, so mass of B over 250 equals to radius B 9 over 5 power 3. And from here you go on to solve. So many of you used power 2. And some of you didn't even have a power. Yeah, exactly. That's area. It's got nothing to do with the mass. When you are looking for the mass, we are checking with the volume, because mass is directly proportional to volume. We are using the idea of density over here. Yes. Nope. You can see me later. I'm not going through some questions I'm not going through because generally everybody did well for that. Okay, now question 13, B part 2. Explain why 1512 is not a perfect cube. I'm glad to see that you have the correct idea, but you don't know how to express yourself. 1512, 2 power 3, 3 power 3. What is the problem over here? The 7 is the problem. What's wrong with the 7? It is not a multiple of 3. The power of 7 is not a multiple of 3. That we are supposed to talk about the powers. So if I have another number, let's say x equals to 2 power 6 times 3 power 7 times 5 power 12. Is this a perfect cube? Is this a perfect cube? Okay, you say no. Tell me the reason why isn't it a perfect cube? The power of 3. What? Yes, exactly. The power of 3 is not a multiple of 3. That's why it is not a perfect cube. So this 2 power 6, is it a perfect cube? Yes. Yes, because the power of 2 is a multiple of 3. Okay, now let's look closely at what this 2 power 6 means. This 2 power 6 is actually 2 times 2 times 2 times 2. How many times? 1, 2, 3, 4, 5, 6. Then we have 3 power 7. Sorry. Times 3 times to the dot. There are 7 times over here. For this number to be a perfect cube, I must be able to separate it into 3 equal groups. This, I've got 6 2's over here. I can group them this way. So as long as the power is a multiple of 3, I can group it into 3 groups. And therefore, it will be a perfect cube. Now compare it with the 7. 7 times of the 3. 4, 5, 6, 7. Now there are 7 of them. 3 itself is a multiple of 3. 3 power 7 is also a multiple of 3. But that's not what we are interested in. We are talking about the power. I can try to group them into 3 groups, but I realize I cannot. 7 is not a multiple of 3, so it can never be a perfect cube. Whereas if I change this to become 6, then this extra 3 disappears. Now I can show you 3 groups. This is one group. This is another group. And of course the last group will be 2 power 2, 3 power 2. Get it? Sorry? Okay, so he's bringing us to, this is actually the foundation. We learn indices by listing everything down. Then when we talk about cube root, we are talking about power 1 over 3. So if I can write down 1512 over here, power 1/3. Let's see what this gives us. This is 2 power 3 times 3 power 3 times 7, power 1 over 3. And we happily say that, this will give us 2 power 1 times 3 power 1 times 7 power 1 over 3. This is the problem here. Right? And this problem arose because the power of 7 is not multiple of 3. Change question now. Are you able to prove whether a certain number is a perfect square? What is the key word? Multiple of 3 again. Perfect square. Then we have to deal with whether the powers of the factors, whether they are multiples of 2. Yes?
So what tells you that when you group the number, you cannot get a perfect number?
Because you're just using your calculator. What? Why would they give you 1 mark for using a calculator like that? Okay, so and they want you to explain. What you did was to punch in and you say, my calculator say like that means like that. You're not explaining. So the explanation over here, not all powers of factors of 1512 are multiples of 3. Example, 7. Not all the powers of the factors are in multiples of 3. So you have to extend this yourself. If you are talking about perfect square, you look whether all the powers are multiples of 2. Next, part 15, part B. Sketch the quadratic graph. Also horribly done. You can complete the square, but you don't know how to sketch the graph. This is the same. Okay, they just put a y in front. From your completed square form, you are able to tell the turning point. Can get turning point. Okay, all look up, look up. I don't want to repeat anymore. We can get the turning point from the completed square form. In this case, y equals to x squared minus 4x minus 7. Are we expecting a parabola opening up or down? Opening up, how do we know? Coefficient of x squared is positive, so it opens upwards. It's like a smiley face. So it has a minimum point. The turning point is a minimum point. So what is the smallest possible value of x? Of y?
-11.
How do you get -11?
The square must be 0.
This square over here must be 0. When this is 0, 0 minus 11 will give me -11. And that will be my smallest value of y. You can't get smaller than -y because this perfect square cannot be negative. If this boxed up value is a negative value, then yes, the answer can be smaller than -11. But it cannot be negative. It is a perfect square. So its smallest value must be 0. Then When does this box start? X minus 2 square equals to 0. When x equals to 2. So you have to identify, oh, x equals to 2 corresponds with y equals to negative 11. To negative 11. This is my minimum point. Next, we need all the intercepts. If they even tell you where to list down all the intercepts. So I know it is going to be a parabola opening upwards. It has to look something like this. Now, x-intercept easier to find or y-intercept easier to find? Y easier to find, right? Just sub x equals to 0. Do it. What do you get? Negative 7. Okay, so it has to cross at negative 7. So if it crosses at negative 7, then it has to continue up, right? Yes. And it also has to continue up the other way, right? What do you think of this curve?
Wrong.
What's wrong on the right side? Yeah, why you curve this way? Wow, so many of you actually curve this way. Get so irritated. You have to curve symmetrically. Okay, curve upwards this way. Okay, this is not very well done. So here, curve up. Over here, curve up also. Please take note that they are not straight lines. We can find the roots. In fact, you need to find the roots. I haven't finished yet. No, you should show how you get the values of the roots. There isn't much to start what. So from here, we are going to find the x-intercepts. That means y equals to 0. The curve is y equals to x minus 2 square minus 11. Watch. All look up at how I do this without mode 3 really quickly. We are now trying to find the x-intercept, which means y equals to 0. This is equal to 0, right? If this is equal to 0, then this is equal to 11, right? Do you agree? What should we do next? Square root both sides. X minus 2 equals to plus minus root 11. Hey, seriously, take very long, man? Yes? Because Emax. Yeah, sorry, that's the answer to you. Because Emax. So x must be 2 plus minus square root 11. Go and get a 3SF value and put them here. Then label y equals to x squared minus 4x minus 7. Now do you understand why I get so angry when I mark this? This is something that you know how to do, right? But you forgot. Sixteen B. Find the angle FGH. This is assuming that you managed to do part A. JFG is 40 degrees. Now all of you, almost everybody can tell me that this is 10 degrees. But that's not the answer. What do we do with this 10 degrees? Times 2. Correct answer, but incomplete answer. What's the reason? What's the reason? Tangents from external point. Tangents from external point. Because when you have tangents from external point, there are a couple of properties that we have. First, one of the most basic properties is that these two lines are equal in length. Next, this angle is equal to this angle. Basically, this line bisects this red angle. Okay? Angle sum of a triangle. This 40? That's in part A. Do you get part A correct? No. Okay, most people did. And I'm very happy to say that there's somebody who remembered how I derived this. Because that one student when to prove that these two triangles are congruent. I clap for you. Because that's how I did it. We can prove that these two triangles are congruent. Because they are congruent, therefore this angle equal to this angle. What? Huh? Yeah, but waste time lah. It's you Waste time. Just quote it. So this is tangents from external point. Okay, the working looks like this. F, G, H. 10 times 2. So we get 20 degrees. The reason is tangents from external point. Okay, and of course before this, you need to show FGJ. Equals to 180 minus 40 minus 130 angle sum of triangle. So this part gives us 10 degrees. That's where the 10 came from. You can multiply by 2, but you don't know the reason. So we have to deduct the mark. Question 17. A kite is not a parallelogram. A kite looks like this. The diagonals of a kite, they are perpendicular to each other. By symmetry, we get these coordinates 4, 0. Now part C, yes. Diagonals refer to the line joining opposite points. This is a diagonal. In Sec 1, we've been telling you diagonals are perpendicular. Me, you didn't understand? Now you better remember. Yes? How do you visualize that it is exactly here? You have to draw it by symmetry. Because it is 0, 4, then this will be 4, 0. Because this line over here is y equals to x. You basically, by right for this question, you don't have to spend too much time to determine why it is 4, 0. But if you want to go into the basic mathematics of it, yeah, okay, this is y equals to x. Then you start to find the gradient. Then you can A-max the gradient over here. Then you can sub in the value. And you can find the other point. You mean, what do you mean? Okay guys, I cannot hear your classmate. I cannot hear Chen Zuo. But it has to make sense lah. You have to look at the question and see whether it is a case where we just reverse it. If the question is exactly like this, yes, go ahead and reverse the x and y coordinate. Next, find the area. Come on guys, you don't have to use the shoelace method. A good half of you use the shoelace method. So seeing that this is a kite, it is made out of two congruent triangles. If I find one area of this triangle, I multiply by 2, isn't it? Now how to find this area easily? Primary school maths. What is the base? The base is 4. What is the height? Yes. 4 times 8, 32, divided by 2, 16. Times 2 triangle, 32. So area, 2 times of half times 4 times 8, we get 32. 18. 18 part A, well done. Part B, very badly done. Because you do not know how to find the area of a hexagon. too many of you think that OM is 6. Hey, look carefully at the hexagon. Since this is a regular hexagon, we are going to have an equilateral triangle over here. So this has length 6, this has length 6. You continue drawing from O to D. This also has length 6. Now I will draw out triangle OCD. O, C and D, 6, 6, 6. M is over here. Now do you know how to find this area? You can use tangent, you can use a variety of ways to find this area. Once you get this area, you multiply by 6 triangles. Then use the formula, volume, 1/3 base times height. This is the volume for a pyramid. It's given in the formula list. But many of you managed to get 2 marks for this, and I awarded it because you know how to use the 33.2 grams for 1 cubic centimeter as well as 975 for 1 gram. What? Square OX. Oh, to get OX, you also needed your OM over here. So this value, let's see, OM is actually root 6 minus root 6 square minus 3 square. So this is root 27. Okay, that's OM. Do you understand this part? Because this is 3 cm, this is 3 cm, and this is 6 cm. Now that we have OM equals to root 27, we draw the right angle triangle for OMX. You get it ready? OM root 27. This is our X, and this is 16. Question 21C. Okay, so this is an explanation question. 30 students from class beta to run a fitness test, same median. If it is the same median, it means that it passes through the same midpoint. So out of 30 students, 15 will be the middle. My class beta is going, the graph is going to pass through this point. They have the same median. But class beta has a higher interquartile range. So the interquartile range, for that we need to identify how we generate the interquartile range. That is from the lower quartile and the upper quartile. Basically upper quartile minus lower quartile, you get the interquartile range. So out of 30, the lower quartile position, 0.25 times 30, we get 7.5. This is 5. This is my lower quartile position. And this over here will be my upper quartile position. This is how we got the interquartile range for class alpha, and it is this much. I, Q, R for A. What about for B? They are telling us that the interquartile range for B is higher. I'll use red for interquartile range for B. So the upper quartile position doesn't change, but they say that the interquartile range is bigger. So let me just draw it longer, maybe somewhere over here. Okay? Then the lower quartile position, since it is wider, this is now a wider interquartile range for B. Okay, pictorially it looks like this, which means that I have a point here. I have a point here, And since they have the same median, it's going to pass through this part. Joining these 3 points together, whether it's a curve or a straight line, I don't really care. Can you tell that it is gentler? This is the idea behind it. If they tell you that the interquartile range now is narrower, what do we expect the graph to look like? Steeper. Okay? So, in part C, we will say that the slope for class beta is gentler. Unless steep also okay. Okay, and that's the last question. Okay, so now if you have, that's the last question.